it is loopless and has exactly one spanning tree. Loopless means no cycle. No? Whenever loop will be there, then cycle formation is occurring, right? The one edge only itself it is forming a cycle, right? So obviously it is acyclic, so no loop is there. Okay, then it has exactly one spanning tree. Yes, it is connected, right? And n minus 1 edges. A tree has n minus 1 edges connected, acyclic. Means to say what? It is having exactly one spanning tree, that is itself only. There is no other spanning tree. If you remove one edge, this will disconnect the graph, right? And it is already a tree. Clear? So that will be its the only spanning tree. Clear? Or you can just prove like this. Then you take it as loopless. The graph G is loopless and has exactly one spanning tree. Then you need to show that G is connected plus acyclic. So connected because it is having one spanning tree. And whenever one spanning tree is the least connected part of G, right? That is connected plus acyclic. Okay, part of G. So if it is loopless means no loop is present, then we need to just check whether some cycle is present or not. Because it has exactly one spanning tree, that's why acyclic. Or you can also do like this. Even if G is tree, then obviously connected plus acyclic, right? And acyclic means no loop will be present if it is acyclic, right? And what is also given, that is G itself is a spanning tree. Why is it? Why is it true? Yeah. G itself is a spanning tree. Why you can say this one? When Z is a tree, itself is a spanning tree or not? Tell me. For example, you have this one. How many spanning tree exist? Or in other words, that is G is the spanning tree of itself. Is it true?
Yes, ma'am.
Spanning the graph, which is a tree. Yes,
Yes, ma'am.
true. Right? So G itself is a spanning tree. Now we need to prove it has exactly one spanning tree. So suppose there are more than one spanning tree, then what will happen? Edge difference होगा. Otherwise vertices तो same ही रहते हैं, right? सभी spanning tree में vertices तो same ही रहते हैं. So suppose the other spanning tree is like this. Okay, this edge. And this edge is not present over here. Now, what will happen? We have just seen that if you have T and T dash, two spanning tree, then one edge that is only present in T, that is this edge, and you subtract it, okay, from T and add this edge, that will form another spanning tree, right? Or you can just say this is also the subgraph of this one. E and E dash. This is your E. This is your E dash. This is also subgraph of G. This is also subgraph of G. Then what will happen in G? Cycle formation will occur, na? Because G वाली S भी present रहेगी G में, right? So, but G is what given? Yeah, G is given what? What type of graph? Acyclic, na? Tree. So this kind of scenario cannot occur in G. That's why exactly one spanning tree होना necessary, right? So anyways, remains to prove G has exactly one spanning tree. Suppose G contains another spanning tree. Okay. So So G itself was a spanning tree. Another spanning tree means it it is not isomorphic to G, right? It is not synergy. Okay. Then T contains an X, E, which is not present in T, not present in the first spanning tree, right? Now you say this T, the new spanning tree, the other spanning tree can contain some edge which is not the part of G. G में ही नहीं है. ऐसा हो सकता है?
No, ma'am.
Are you getting this question or not? Yes? Hello. Am I audible?
Yes, ma'am, audible.
Yes, ma'am.
So this was connected acyclic loop plus it was done. G itself is a spanning tree because it is connected and acyclic. Okay, and obviously it will be having n minus 1 edges, and that is the also definition of spanning tree. Means for spanning tree also you need n minus 1 edges. Now you need to just prove exactly one. So suppose there are at least two spanning tree, that is G itself, it is already the spanning tree. So some other spanning tree exists which is not the same as this one. Okay, so both the spanning tree सबके साथ कोई भी हो, every spanning tree contains VG, right? Vertex set तो रखेगा ही, edge set में difference होगा, right? So this spanning tree, if it is different, means some edge will be present in T but not present in, some edge is present in T but not present in G. Can it happen? He is the spanning tree of G and वो ऐसी edge रख रहा है जो G में present है ही नहीं. Then it will not become the subgraph, right? Spanning tree होना तो बहुत दूर की बात है, right? Are you getting it? So
Yes, ma'am.
this will contradict our statement that T is the spanning tree, whatever we have assumed with this one. Okay, so in this case, it will not become the subgraph. Yeah. The reverse is what? G is loopless and having exactly one spanning tree. Then what they are just proving again by contradiction. G is loopless, has exactly one spanning tree. Means to say connected, because spanning tree is the connected subgraph of G, right? The least connected subgraph is the spanning tree. So that's why spanning tree अगर है exist कर रहा है तो वो G का subgraph तो होगा, and G का subgraph है means G is also connected. Clear? Now just remain to prove for this G to be tree is acyclic, na? Acyclic. So suppose G contains G is not acyclic, means G contains some cycle. Then what will happen? There will exist more than one spanning tree. For example, if there is, how many spanning tree exists for this one? Many, na? This one. This one is also spanning tree. This one is also spanning tree, right? Okay, so many spanning tree exist whenever it is containing a cycle, because whenever we have a cycle, then we can remove any one edge from the cycle and remaining the others. Okay, so इसमें ये वाली remove किए, this one ये वाली remove किए second, and this में third वाली remove किए. So we got more than one spanning tree, which is contradiction because it is having exactly one spanning tree. So that's why our assumption that is G contains a cycle, that is wrong. So G is acyclic, and G is acyclic plus connected means G is a tree. Clear?
Yes, ma'am.
Yeah. Just try to TV tree with average degree is given. Determine ND. N of T means N order. Determine N of that tree, and for the given degree, average degree it is given, and T is the tree. How can you determine? This is just the numerical formula, right? Use that. We have done it. Degree and how we have we relate n or m like that, and just use t being a tree. Yes, right. See, average degree they here, right? What do you understand by average of anything? How you find average?
Sum of all observation by number of observation.
Yeah, sum of if there are n number of vertices v1, v2, and so on up to vn. So I is running from 1 to n, right? Divide by n. Degree of v1 plus degree of v2 plus degree of v3 and so on up to degree of vn. And this one I have just denoted as summation, and this is given as a. So from here, can you find n? Average degree they रखी है. Now you can easily find n because you have the degree sum formula that connects degree with size, and size for a tree you already know. Yeah, just try it. Let's just put the value of this one in terms of m for every graph, but you have the degree sum formula.
2 times of size.
2 into size, right? And size of a tree is
N minus
yeah.
1.
Size of a
N
tree
minus 1.
n minus 1. So 2 into n minus 1 divided by n is equal to a. So from here you can calculate easily this n in terms of it. So just find it and tell me the value. So just replace this with whenever tree, then 2 into this will be 2 into n minus 1, because for tree the size is n minus 1, right? So 2 into n minus 2 2n minus 2 divided by n is equal to a, and then cross multiply it, and what are you getting? 2n is equal to that is 2n minus an
Ma'am,
is equal
n
to
equals to 2 by 2a.
2 by
2a. 2 minus a. 2 minus a.
2 minus a,
Yes, ma'am.
right? By 2 minus a. By degree sum formula we are given the average degree, and average degree is this one. Okay, we'll just written is this one. For tree we have this one. So we got 2 divided by 2 minus a. Clear? Is there any doubt? Now I explained this one yesterday. So can you explain it again? Have we proved this? We used that theorem, that is degree, that is diameter of G is given as at least 3, then diameter of its complement of any graph will be at the most 3. And here we need to prove that degree a simple graph given as diameter of G is at least 4, then we need to prove its complement will be at the most 2. Okay. To prove, suppose this is not by contradiction, we are just trying to prove. So if this is not at most 2, means to say this is bigger than 3, bigger than 2, right? Less or equal, not less or equal, not less, not equal, then what will happen? Diameter of G complement will be greater than 2, and greater than 2 means greater than equal to 3, right? Diameter is a number, right? So diameter of G complement is at least 3. Then complement of complement will be by that theorem, because G is a simple graph, its complement will be again simple graph. Okay. So diameter of complement of complement, because this was the graph that is having diameter is at least 3. So complement of this graph will be at most 3. Right? We have done it. And complement of complement is isomorphic to itself. Right? That is the same as negation of negation. Right? So diameter of this is isomorphic to G. So diameter of G is at most 3. Is it possible? Is it possible? We have got diameter of G is at most 3.
No, ma'am. Two.
Not possible, because given it is at least 3. Right? And but we have used the complement of any graph. This is also graph, no? Complement of diameter of complement of any graph is at most 3. If it is diameter of the graph is at least 3, right? Then we are getting some contradiction to this one. So whatever we have assumed is wrong. That's why it has to be at most 2 only, not more than 2. So this statement was wrong. Clear? Or any doubt? Yes? Okay. Uh, Try to do this one.
Clear, ma'am.
True or disprove? If Ni, that is N1, N2, and so on, denotes the number of vertices with degree I. That is, degree of some vertex is equal to I, and the number of those number of vertices is your Ni. Okay, means there are how many vertices? Degree 1 vertices, there are n1 number of vertices. Degree 1. Degree 2 vertices, there are n2 number of vertices. Similarly, degree I vertices, there are ni number of vertices. This is just number of vertices denoting, not the vertex. Clear? In a tree, given its tree. Okay, so this is ni denotes the number of vertices in a tree. Okay, this one. Then summation of I into ni, n subscript I, depends only on order of the tree. Is it true? Yes. And the hint is use the degree sum formula and just tell me whether it is true or not. Yes. Anyone? Okay, degree sum formula में क्या होता है? Yes. Tell me degree sum formula.
Ma'am, summation of degrees will give you the 2 times of size of the graph.
And size of tree is n minus 1, right? So 2 times n minus 1 for tree. Yeah. So summation of vertices, degree of vertices means If there are there are first 5 vertices with degree 1. So then what do you do? Degree of V1, degree of V2 plus degree of V3, degree of V4 and so on. In सबकी degree same है. So what do you do? 5 into degree, clear? Whatever the degree, if degree of these 5 vertices is suppose 2, so you will be added 2 into 2 into that is 2 plus 2 plus 2 plus 2 5 times, so 5 into 2. Similarly, if there are I number of, that is ni number of vertices with degree I, so summation में क्या होगा? I will be added how many times? Ni times. Yeah.
Yes, ma'am.
And similarly, you can just say 2 will be added n2 times, 1 will be added n1 times. Clear? And so on. Whatever I will be added ni times. And this is giving you 2 into n minus 1. So can I just write, if I is being added ni times, so can I write I into ni and summation of this one? This one is what? Given. I is running from greater than equal to 1, 1 to k. Okay. So this is 1 into n1. जितने भी 1 degree थे n1 times plus 2 into n2 plus 3 into n3 and so on, I into ni and so on up to k into nk. This is giving you 2 into n minus 1. Understood? Why I have written this I into ni?
Yes, ma'am. Got it.
Yes, ma'am.
Okay. So is this the function? Is this the function of n only?
Yes, ma'am.
In other words, it is depending only on n, right? This is giving you 2 into n minus 1, right? So yes, this is true. And ni is the number of vertices with degree I. That's why summation of all the degree will be summation of I into ni, right? This one. And this is giving you 2 into m, and for 3 it is m is equal to n minus 1. So this is only depending on n. Now, similar type of question is this one. And this one is the last question, I think. Yeah, just try it. T be n vertex tree, so n vertices are given, having one vertex of each degree I, with I is running from 2 to k. That is, for degree 2, I is running from 2 to k. Na? So for degree 2, there is one vertex. For degree 3, there is one vertex. For degree 4, there is one vertex. And so on up to degree k, there is how many vertices? One vertex. Okay. And the remaining out of n, this starting from 2 to this one, that is yeah, we have degree of v1, okay, plus degree of v2, summation and so on, degree of v2, degree of vk, okay, degree of vk plus 1, and so on up to degree of n. And this is vn actually, because there are n number of vertices, v1, v2, vn, and this is giving you summation of degree, right? And this is giving you for tree, what is it? 2 into n minus 1. Clear? The degree of first vertex, second vertex, kth vertex, k plus 1th vertex, and so on, last vertex n. So from here, one vertex कौन सी degree का दिया हुआ है? Degree I, and I is running from 2 to k. So degree is equal to 2. Okay. Degree is equal to 2. Suppose we have the vertex second is having degree 2, vertex 3 is having degree 3, and so on up to k we have degree k. Okay. So from 2 to k, what is given? Only one vertex is present. We will be added 2. So 2 के corresponding V2 का degree 2, V3 की degree 3 and so on up to k की degree k. Are you getting it? What is given? One vertex for each degree I. Is जो भी degree 2 थी उसके corresponding V2 एक ही type का vertex. Okay. And so on up to k. Okay. Now the remaining n minus k plus 1. The remaining vertex are n minus k plus 1. See, this is starting from k plus 1, k plus 2 and so on up to vn. So this is n minus k and plus 1. V1. Okay. If it would be from v1 to vk, it is n minus k, but now it is v1 left, right? But these are given as leaves. And what do you understand by leaves?
Degree 1 vertex.
Yes. Degree 1.
One vertex.
Here. So degree of v1, because v1 is leaf, vk plus 1 is leaf, and so on up to vn is a leaf. All these n minus k plus 1 vertices are leaves. So we will be just adding 1 for v1 and so on from here to here. Then for vk plus 1 again 1 and so on up to again 1, because these n minus k plus 1, these are given as leaves. Clear? So this is one, don't get confused. Now this is right hand side is 2 into n minus 1. Okay. Now determine n. We are given k, okay, and we are given the number of vertices with degree I and also the number of remaining vertices. Means all the vertices are given. That is, all the vertex degree is given below, right? And it is asked about n. Can you find it? What is n? So up to it is 1, 2, 3 up to k. It is what? First k numbers. Sum of first k numbers. What is it? And these are n minus k. Right? What about this one? K into k plus 1 by 2. Is it? First k numbers summation plus this is n minus k times. 1 is being added how many times? K plus 1 and so on up to n. So n minus this one. Right? N minus k. Okay. Is equal to 2n minus 2. Okay. So 2 will be over here and n is over here. So it will be n is equal to finally k by 2 k into that is k into k plus 1 by 2 plus n minus minus plus. So then it will be plus 2. Right. So that is k into k plus 1 by 2 plus 2 minus k is equal to n. And solve it, you will be getting the formula. Got it? How I explained? Now its solution. This is, there is one vertex of each degree is equal to I. Degree जो भी I है उसकी corresponding one ही vertex है. Okay, due to this one. So Vi is the vertex corresponding to these degree. So V2 का 2 degree, V3 की 3 degree and so on, Vk की k degree. The remaining n minus k plus 1, these are leaves, means I is equal to 1k corresponding Vi, that is V1 is leaf, Vk plus 1 is leaf and so on up to Vn is a leaf. Means to say degree of all these vertices will be 1. By degree sum formula for a tree, we have the summation of degrees of all the vertices is equal to 2 into n minus 1. Okay. Then you open it. From 2 to k, it is given degree over here is 2. plus degree of all here is 3 and so on up to k. So यहाँ तक degree k है, right? And this one and this one. यहाँ पे degree 1 है. These are given as leads. Okay, so this is 1 plus 2 plus 3 and so on up to k. Okay, you can add it there itself only, or what do? You can just take up to k minus 1 because this is again n minus k, so k to k cancel. We have got n minus n right hand side and plus 2 it is on left hand side. So what do you got? N is equal to 2 plus k into k minus 1 by 2. The same thing whenever I was explaining, I just took up to this one, that will be k into k plus 1 by 2. Then you need to again subtract this k, okay, and here it will be 2 plus 2 and is equal to 2n minus 1, that is n. Okay, so if you subtract it, this will be is as it is, and this will be k into k minus 1. Is there any doubt? Yes? Is there any doubt? Now, if I give you that there are 3 vertices or 5 vertices, okay? So there are 3 vertices with degree 1 or with degree 2, you can just say. 3 vertices, there are 3 vertices, V1, V2, V3, you can just take with degree 2. Okay, and I can give you the other 2 vertices are having same degree. Okay, whatever same, we don't know. So you can just calculate, just assume it x or anything else, the remaining 2 vertices. And also I gave you, yeah, there are 5 vertices, means size of this tree will be 5 minus 1, right? Order minus 1. So summation of these degree of Vi, this is giving you 2 into 4. Okay, so from here, can you find x? Whatever the remaining 2 vertices are given, can you find the degree of that? Just from by using degree sum formula, okay, for a tree. So first 3 vertices are having 2 degrees, so 3 into 2, 2 will be added 3 times, plus the remaining vertices are having same degree. So we have assumed as x. So x plus x, 2 into x, and this is giving you 2 into 4, 8, right? So this is 6. So 2x, 8 minus 6. So x will be 2 by 2. So degree will be 1. So here degree is 1. The remaining 2 vertices are having degree 1. Similarly, I think if someone gave you this kind of question, then you will be able to answer it, right? Always remember for this one, for tree, the degree sum formula is reduced to this one, okay, 2 into n minus 1, because m is equal to n minus 1 for tree, okay. Is there any doubt? Yeah?
No.
Okay. Tomorrow, I'll start this section 2.2. In this one, we'll be discussing about spanning tree again and how many spanning tree exist or not. So total number of spanning tree, that is total number of simple graph with n vertex are 2 raised to power nc2. Okay. Clear? Simple graph I'm talking about, not the directed one. Directed vertices, directed graph are 2 raised to power nc2. Clear? Okay, that is oriented graph. And the tournament is again 2 raised to power nc2. And the simple graph is again 2 raised to power nc2. Okay, so these are total number of graph with respect to to this one. So out of these, first we'll just try to find how many of these are trees, and if some are not tree, then we can reduce them to tree by just removing the edges from the cycle. Okay, cycles. And how many such spanning tree will exist? So we'll be discussing what Cayley formula. Okay, that is giving you the total number of trees will be n raised to power n minus 1. Okay, and out of these n raised to power n minus 2, some are isomorphic, some are not. Okay, then we'll discuss about spanning tree and total number of spanning tree, counting the spanning tree. Okay, clear? This we will discuss tomorrow, and I think tomorrow it will be over 2.2. Okay, thanks all. I stop here.
Thank you, ma'am.